Hello guys, we are back with our next tutorial. In this tutorial, let us go through concatenation or composite transformations. So basically you may ask me that according to our previous lecture, we did the different types of rotation, translation, scaling, shearing, right? So you may have a doubt that on a single matrix, can we do them all like one after the other or anything like that? Yes, it is possible guys. So whenever you do some different operations, we will be doing them combinedly. So one after the other in that way. Okay. So now let us go through this topic guys. So concatenation of a transformation refers to the concatenation or multiplying of the basic transformations. Affine transformations like translation, rotation and shearing, etc. So rotation about a fixed point or an arbitrary point. So to do this, so we need to rotate a particular object with a fixed point. Fine. Okay. So to do this, we will be following these steps guys. So let us assume you want to rotate the object with respect to this point. This is the object and you want to rotate it along with this point. So initially the first thing that you will be doing is you will be bringing that point to our origin. So once you do that, you will be following the step that is nothing but translation. Okay. So once you do translation, you will be doing your rotation like 30 degrees, 60 degrees, 100 degrees like that, you will be rotating it. So once you've done the rotation, you will be retracking it back to your original position. So this is nothing but inverse translation, you can say. So for that, the matrix will be P dash is equals to the initial position P with the translation, rotation and inverse translation. So you can write it in this way guys. So here X and Y will be your position to where you want to transfer it. So I hope everyone got a small idea on this. Okay. So now let us continue with scaling. So even scaling is also possible guys. So scaling, I hope everyone remembers about scaling. Scaling is nothing but enlarging the image or making it small in all directions. Remember that. So if the image is originally here and this is your point, arbitrary point, so you will be bringing it to the origin and you will be doing scaling. Either you will be decreasing or increasing. Here I decreased the size, so scaling is done. Now you will be inverting it back to your original position. So that's nothing but inverse translation. So P TST, fine. So in this way you will be doing it. So I hope everyone got a small idea on this. So in the next tutorial we will be going through open transformation matrix guys. These topics we'll be discussing in our further lectures. So basically few important, sorry. So basically these all translation, rotation, scaling, how you will be doing in OpenGL guys. So these are the few functions which we'll be using. Those are nothing but rotate F, scale F, translate F. Rotate means we'll be having a particular angle along X axis, Y axis, Z axis, along which axis you are doing. Similarly, scaling means in which axis you need to scale it, or translation means only within which axis you need to move it. So these are the few OpenGL commands for transformations guys. So in our record or in our lab book, you can find a lab program guys. Please practice that. Whenever the related question comes, you can just write the program. Fine. Okay. So I'll be skipping this viewing of positions guys. And in the next tutorial, we'll be going through the projection and its types guys. Because we are lacking on time, I'll be just going through some important topics. So in the next tutorial, we'll be going through projection types. Thank you. Thanks for watching.